Two resistors, the same value. If I connect them together, does the resistance go up or down? Today we're going to look at series and parallel resistors, not just the theory, but actually build them and measure what really happens. So let's start with resistors in series. They're connected end to end. That means there's only one path for current to flow. It means the same current flows through both resistors. And the total resistance is simply R1 plus R2. Each resistor has a voltage drop across it. So therefore the total voltage across both resistors will equal to the voltage drop across the first resistor plus the voltage drop across the second resistor. So if I said resistor 1 was 220 ohms and resistor 2 was 550 ohms, I would simply add these together and that would be 770 ohms in resistance. Series always increases resistance. So let's start by building our series circuit. I'm going to use 10 kilo ohm resistors to make this easier for all our calculations. And I'm going to place one 10 kilo ohm resistor on the positive rail, and then one to the negative rail at the bottom, making sure they connect to the same position on the board. I'm going to use two leads, one on the positive, one on the negative. And if I set my multimeter to 20 kilo ohms, we should measure 20 kilo ohms on the output. And it's just under, which would be about right, as there is a 5% tolerance on this. So parallel is different. Now both resistors are across the same 2 points. That means the voltage across each resistor is the same. But because the current splits between the two, that means the total current, IT, is equal to the current in the first branch plus the current in the second branch. So here's the important part. The total resistance goes down. As you can see, the formula's over here. The total resistance is equal to 1 over R1 plus 1 over R2. If we only have two resistors, like what we can see in this diagram, we can use this formula, where the total resistance equals R1 times R2 divided by R1 plus R2. So if we have two 1 k ohm resistors, we can say resistance in total equals 1 times 1 plus 1 plus 1. So the total resistance equals 1 divided by 2, which equals 0.5 kilo ohms. As you can see, because we've got more paths, it becomes easier to current flow around, so the resistance always decreases. So let's build our parallel circuit, and I'm using 10 kilo ohm resistors once again, and we should expect 5 kilo ohms as the measurement. So if I place them on the same row, place a connection between them. Been a bit tricky today. I'll go and to the positive, and on the other side out to the negative. Then let's put two spare wires in to connect our rails. So if I was to measure this on the multimeter, let's set this to 20 kilo ohms of resistance on the measurement again. Connect one end and the other. And as you can see, roughly 5 kilo ohms, which is our expected measured value. Now let's try measuring the voltage drops. So let's connect our power supply, our red lead to our positive, our black lead to our negative. I've set my bench power supply to 5 volts, so I'll turn that on. And if I set my multimeter to read 20 volts, and let's take a measurement. Now, as we remember, voltage across a parallel circuit should be the same as the supply voltage. So 5 volts for the first resistor, and 5 volts for the second resistor. This here shows that all the theory matches up with the practical discussions and applications. Obviously there is tolerances involved, and this can be seen by the measurements not quite adding up. However, thank you very much for watching this video. I hope you've enjoyed it, and come back to visit again.